Hello Cloud Growers and welcome to this brief lesson where I'll be talking about NoSQL graph databases. So graph databases are the last type of NoSQL models that I want to discuss. Now there are more, but this group of lessons is just designed to provide foundational knowledge. I don't want to use too much time providing information on database models that you won't need to understand to grasp the core of this course, which is DynamoDB. So far we've discussed relational SQL-based databases, which have a data and relational focus, but those relations are fairly static, being decided upon at schema creation time. We've also discussed a number of complementary NoSQL models, each with their own view on how data is modelled. A common factor is that they all ditch relationships between data from their model, and they gain a significant performance benefit from doing so. So where does a graph database fit? Graph databases are equally concerned with data and relationships. So in that regard, they are unlike the other NoSQL database platforms. There is, however, a strong emphasis on relationships within a graph database, and those relationships have key differences. In a graph database, relationships are fluid and they're persistent. In the relational database world, the relationships are derived from primary and foreign keys, and these are calculated at query time via the SQL processing engine. This is CPU and memory intensive and poses a problem to those using relationships as a core feature of the database, especially as the dataset scales. As you recall, we mentioned in a previous lesson that many-to-many relationships weren't possible in a relational database without significant adjustment to the data model, i.e. using linking tables. In practice, this is tricky to do and requires planning, and there are performance hits to this method. Graph databases support and encourage many-to-many relationships. In fact, this is one area where some of the power of using a graph database comes from. Graph databases can model the structure of certain types of data, such as social interactions, with ease, without expensive and time-consuming database modeling. So let's look at a simple example of a graph database. It should be easier to convey the concepts visually. At a very simple level, graph databases have a few core concepts. We have nodes, we have relationships, properties, and labels. Now keep in mind the functionality differs across vendors, but the ones I've just mentioned should be pretty common. The easiest way to think of nodes is as things or nouns. In many graph database systems, nodes have a type, but more on this shortly. We also have properties, which are the key value pairs which can be used to represent attributes or metadata of objects. We have relationships between nodes, and think of these as verbs. Relationships have direction, i.e. person A works at place B, and relationships always have a start and end node. And finally, we have labels, which allow rudimentary typing or grouping of objects. So let's start with our first node. This is a person object, and as standard contains the name and age properties. So far, this looks similar to most relational database systems. Let's add two or more nodes, but this time they are of the type company. A similar set of attributes, but this time the age represents the company incorporation or creation age. Now Malcolm is an IT contractor and he has done work for Bad Corp and Big Corp on a regular basis, so let's model this with some relationships. And so far, still, this isn't much different from a standard relational database, as this is a one-to-many relationship. Let's add Daniel to the mix, and he has also done some contracting work for Big Corp. So you can start to see a many-to-many relationship where Big Corp has many employees and an employee can work for many companies. In the relational database world, this will be difficult to model and computationally challenging to work with at scale. With graph databases, this is easy. We mentioned above that relationships are directional and have a start and end node. Let's model the inverse relationships for Malcolm and Daniel, and for those who are keen of eye, I'm missing one to keep the diagram clean. So far, this is beyond what a relational database system can do as standard, but nothing super impressive. So let's add some information on those relationships. This adds additional information richness to those relationships and makes them more useful. There isn't a limit to the properties for a relationship, so we could add more. We could also add another person into the mix, perhaps Phil. And maybe Phil is Malcolm's manager. Equally, Dan could also report into Phil. You should start to see that graph DBs are extremely useful when context or relationship between things, node, and objects is the core of your product. Graph databases don't have the concept of SQL to query the information, but many have a comparable language specifically suited to working with the graphing model. One example is Cypher, which is the querying language which comes with the popular open source GraphDB implementation, Neo4j. If you're interested in emerging database technologies, I highly recommend that you look into GraphDBs. They are rapidly gaining in popularity, especially in web apps with a social or relationship component. Well, that's the end of this mini lesson and this lesson series, Cloud Gurus. I hope you've enjoyed the high-level introduction into each of the main NoSQL database types. If you do have any questions, feel free to contact me directly or via the Cloud Guru forums, and I'll endeavour to help. Don't worry too much if anything in this section seems conceptually foreign or difficult to understand. Spend some time going over key value and document store database types, and that will give you the basis you need for the main content of this course. Feel free to complete this lesson and move on to the next.